Alright, welcome back, class. We're going to be looking at Unit 2, Activity 1, Collecting and Summarizing Data. So, well, data. I don't know how you're going to pronounce it, but that's how I'm going to. So we're looking at two variable statistics today. So there's going to be kind of like a cause and effect thing, and we're going to look at where a positive relation happens and what that means. Basically, looking at different types of data with two variables. So the first bit we see here is smoking is a leading cause of cancer, fluoride prevents cavities, seatbelts save lives. So thing about these statistics is that when they happen, we like the seatbelt thing here, seatbelt save lives, they became mandatory, right? The fluoride prevents cavities, this one here, fluoride was added to drinking water in some areas to make it better. But then there's different questions that get asked. Like below here, we see that is there a relationship between the height and weight of a person? Does a student's mark in mathematics relate to a mark in English? Like, probably not, but you never know, right? And is it true that the more student studies, the higher marks there will be? These are all different examples of two variable statistics. The next part that we end up talking about is graphs, and luckily we talked about some of this in the first lesson, I believe, when I was talking about graphing lingo. So if we look at this, we're going to look at the different parts of a graph. So right here we see that we have the y-axis there, the x-axis there, and what's called the origin, which is this part right there where there's a 0 and a 0. Now each point on the graph, so if I had different points here and here and here, they all represent different stats. And it correlates to a value on the x-axis and a value on the y-axis. Like there, if I had a point way up here, it'd be around 250 and around 250, right? You always go x first though, just so we know the point goes x, y. That's a terrible y, sorry about that. And so graphs are good because they can show the facts, they can grab the reader's attention, demonstrates the arguments. It has, like, a good graph will have a title and labels. It's not cluttered, the scale is good and not whole wonky. So why use graphs? So graphs can quickly highlight data you're trying to get across and can convince readers of the point you're trying to make. So when it's not appropriate to use a graph, we're going to go through a couple examples. The first one is the data is very dispersed. We have a nice figure there. This one right here. So you had number of votes, and I'm not sure, there's no title over here, so it just has the different independent Green Party. So it looks like the different parties and then how many votes, and there's just so much data dispersed. The next thing is when there's too few data, so one or two data points. So right here we only had September and June. And then the number of students, so as you can see, like, they're very close together. Maybe if you kept going or had different, you'd see a rise and fall or whatever, but this is not enough data for a graph. Next part is that the data is just too much. So below we see the number of students taking English as a second language at a West High School by first spoken language, and just look at how complicated that is. Just ridiculous. You got Greek, Tamil, Korean, Vietnamese, Arabic, Punjabi, Polish, German, Spanish, Portuguese, Chinese, Italian, French. Like, there's just way too much to show. I don't know what they're even trying to show. And the data has little or no variation. So the number of young adults who exercise at least once weekly by age, like as you can see, it just kind of has the same trend, just straight across, a slight increase, a slight increase. So it's just, there's no point in really using a graph for that. So the next part we're going to talk about is data correlation. So correlation is when there is some sort of relationship between the values, like the variables x and y. So the independent variable, which is known as the x variable, and it's on the horizontal axis here, and the dependent variable, the y variable right here, like as I said, plotted on the vertical axis. So the dependent variable here is very much reliant on the independent variable. So if we look at here, we had variable 1, and y is determined by that one. So we have 2, 4, 6, 8, so 2 is determined, like 2 here gets determined by 2. And as we talked about in the first lesson, there's different types of relationships. So there's positive, negative, no relationship, right? So a positive relationship goes from the bottom left of a graph to the top right. That's how you know it's a positive relationship. This one is a strong positive because all the points are very much congregated right here, all close together along this line. So we have a very strong positive relationship. There's also a negative relationship, which goes from the top left of the graph to the bottom right. And again, this is a strong negative relationship because all the points are pretty close together along that line. But then there's a spread of data, so no relation, which just the points are all over the place. We can't say it's positive, we can't say it's negative, like there's just no correlation. But that's when the data is widely spread. There's also data concentrated, which again, it's all just in this giant, it's like the one above here, but compressed is what it looks like to me. So there, you can't say it's a strong positive, can't say it's strong negative. So there's just no correlation there, no relationship. So I believe that was it for that. Yep, that's it for that content. So you just have a couple of questions at the bottom here. Check your answers by clicking that right there. And different questions are classify the type of linear correlation you might expect with the following pairs of variables. So hours of hockey practice versus goals scored in the hockey game might be interesting. Students' average marks and the number of siblings in their family. Distances from students' homes to their schools and the time they spend on the school bus each day. Amounts of television watched per day, scores on a fitness test, and years without an accident driving insurance rates. This one's a good one. Yeah, so that's all for this video, and I will talk to you on the next one.